In this video, what I want to cover is the top 5 factoring techniques that you need to know when our a is going to equal to 1. The first one is going to be the difference of two squares. Ladies and gentlemen, whenever you see a two-term expression that you need to factor, always think of difference of two squares. If your first term is a square number and your last term is a square number, again, remember square numbers: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, right? Remember all those numbers? If your first and last number are square numbers, then remember you can apply the difference of two squares. So in this example, if I have x squared minus 9, I can rewrite this as an x minus 3 times an x plus 3. So always look to that one first. But this next one sometimes gets students confused because they see two terms and they remember, oh, Miss McLogan always said difference of two squares. But I didn't always say. I said always look for difference of two squares first. Notice 5 is not a square number. So therefore, I cannot use my difference of two squares here. So what I do need to do, though, is see, all right, is there anything they have in common? And you can notice that they both have an x, right? Because technically, I could rewrite this as an x times x minus a 5x. That's the exact same idea, right? So remember, when we're trying to factor, our idea of factoring, ladies and gentlemen, is taking an expression and rewriting it as a product. So what else I can do is what we call the factoring out the GCF. What they mean is the greatest common factor. So we say, what is it that they share? Well, they both share an x. So what I can do by factoring that out, that's technically like me dividing out an x. By dividing out an x, I can now say what is going to be left over. I will just have a x minus a 5. But again, remember my goal, guys, is not to divide out randomly an x. I got to keep this equation pure. Whatever I have in my factored form has to be the exact same value as what I had before, right? X minus 3 times x plus 3 is the same thing as x squared minus 9. If you were to multiply this using FOIL, you're going to get an x squared minus 9. The same thing over here. When I divide out that x, I got to take that x and rewrite it on the outside of the parentheses. I'm going to take my quotient and rewrite it on the inside of the parentheses. Because if I multiply this back, x times x is x squared, x times negative 5 is a negative 5x. I have to keep the expression preserved. Factoring is not changing the value of your expression. It's just rewriting the expression as a product. So remember, division and multiplication are inverse operations of each other. So by dividing out this x, I just need to make sure I'm rewriting it as a product, okay? And again, you can always check your answer again by multiplying it back out. The next 3 is where students get confused because now we're going to have quadratic trinomials. And students usually don't like quadratic trinomials. But remember the first thing I said when you're dealing with binomials, always look for difference of two squares. Look for the square number in the beginning and the end. When you have a trinomial, do that exact same thing. Is the first number a square number? Yes. Last number a square number? Yes. Is the middle term 2 times the square root of the first and last number? I kind of said that fast. Let's go through it again. So what you're going to do is you're going to take the square root of your first number, which in this way, square root of 1 is just going to be 1. And you're going to take the square root of the last number, which in this case is going to be 5, right? Square root of 25 is 5. You're going to multiply 1 times 5 times 2. 1 times 5 times 2 is going to be 10. If that is your middle term, that means you have a perfect square trinomial. What that means is the factored form of this is going to be a binomial multiplied by itself. So therefore, I can just rewrite this as an x plus 5 quantity squared. Now, sometimes students, that takes a little practice. I get it. So another way that we can think about this is when I'm looking at an expression like this, what I'm trying to do is identify what two numbers multiply to give me a positive 25. I'm going to change this problem. What two numbers multiply to give me a positive 25, but add to give me a positive 10? Well, that's going to be a 5 times 5 is 25, and a positive 5 plus positive 5 is 10, right? So you could rewrite that as an x plus 5 times an x plus 5. And therefore, you could see how that can be simplified to an x plus 5 squared. All right, let's get over to the last two examples. I want to change that just because this had two positives, so I didn't want to do two positives over here. But actually, you know, I don't know. Why am I changing things up? Let's just keep it the same. OK, so notice 6 is not a square number, so I can't use this idea. They don't share anything in common, so I can't use this idea. I don't have two terms, so I can't use that idea. So what I need to do is, again, go back to that idea of asking myself, what two numbers multiply to give me a 6, a negative 6, and then add to give me a negative 5? Now, you know from the factoring tree of 6, we have 6 times 1 and a 3 times 2, right? And here's the thing that I want you to understand. When my last term is going to be a negative, so I don't care about the positives and the negatives in this case. What I want you to focus in on is when the last number is negative. That means the larger of my two factors also has to be negative if my middle term is negative. If my middle term was positive, then the larger of my two factors has to be positive. So we're going to say what two numbers multiply give me -6. That means one of them has to be negative. And then what we're going to do is say, well, which of these have a difference of a -5? Well, obviously you can see it's only the first answer, right? These two have a difference of 5. But which one's negative, which one's positive? Well, again, since my middle term is negative, that means that I need the larger of my two factors to be negative, which in this case would be a 6. And that is going to be your factor form. Now, what about if my last term is positive? Well, that means both of my factors are either going to be both positive or both negative. So now what I'm trying to do is, rather than trying to find the difference like I did with the negative, now I'm trying to find the sum of those two factors to get a 5, right? And they both have to be the exact same sign. So you can see it doesn't really matter if I change this to a positive or negative on the middle, because if it was negative, then both factors would be negative. If it was positive, both factors would be positive. In this case, since my last term is positive, I know both factors have to be exactly the same. So which of these two numbers add up to give me 5? You can see that's going to be a +3 and +2. And ladies and gentlemen, if you practice all 5 of these techniques or going through problems like this, then you are going to be a much better student at factoring. And I know you're not going to be as frustrated or stressed out when you have a problem to do on your own.